Okay. Okay, so on the warm up there, we talked about how to change the value B for our exponential based on how many times you compound. So you take your interest rate and you divide by how many times you compound per year, because interest rates are always annual interest rates. So you got to divide by how many compounds per year. So now you have the interest rate per compounding period, and it's always 1 plus. And then the other thing that you will have to change is the exponent. You have to measure each problem in the units that it mentions. So part A, annually, number of years, part B, quarterly, number of quarters, and part C, monthly, number of months. Okay, so I am going to do a couple things here. Since I'm able to share, I'll put my camera on so you guys get to see my masked face just like everybody else does here. And okay, looks like Danny just joined us. Might have forgotten about early Mondays. Okay, so how are we doing on? Okay, so let's take a look at our values here. So on part A, the B value, 0.09 divided by 1 is 0.09. Add that to 1, you get 1.09. On part B, you end up with 1.0225. So notice that the more often you compound, oops, gotta unfreeze that. The more often you compound, the lower your B value is because your interest rate is for a shorter period of time. So over here, we get 1.0075. Okay, so even though this B value down here on part C is lower than the other two, we are going to compensate for that by the exponent. So for the exponent, we are going to have the number of periods. So everything's going to be measured in the number of periods in 12 years. Part A, our periods are yearly, annually. In 12 years, there are 12 years. So the amount of money he would have would be y equals $1,000 times 1.09. He's going to get 12 interest payments because he is getting his money compounded once every year for 12 years. So the bank is going to pay him 12 different times. So I would take my calculator over here and I would type in 1,000 parentheses 1.09. Raise that to the 12th power. It is best if you just type the whole thing into your calculator all in one line. I saw people on Friday that were trying to multiply like these two together. Don't do that because the exponent has to be evaluated first and then you multiply by 1,000. But if you enter it like this, the calculator knows that. The calculator knows the order of operations. So if you just enter it on the calculator the exact way that we write it on paper, including the parentheses and the exponents, and then hit enter, you don't have to do it in 2 steps. You can just do it in 1 step. So it looks like he's going to have 281266. So this would be 281266. So $2,812.66 if they compound annually. If they compound quarterly, oops, I didn't write my thing down. And there's Leilani. Okay, so quarterly, we have our B value, and we know that we are going to be counting quarters. So Y equals, you start with $1,000. Your multiplier is 1.0225, but quarterly for 12 years. Quarterly means 4 times a year. So 12 years, 4 times a year means he's going to get his money compounded 48 times. So he's going to have the interest compounded and calculated 48 times. So again, I'm going to grab my calculator and I'm just going to type that in. If I can move it over. There we go. I'm just going to type it in exactly as written. 1,000 parentheses 1.0225. Raise that to the 48th power. And in this scenario, he would have $2,909.64. So 2,909.64. So a little bit more. Okay. So not a big difference, little under $100 difference versus the annual compounding. And then our last one here is y equals 1,000. Sometimes my zeros look like sixes. 1.0075. We are now compounding monthly, still 12 years. 12 months in every year for 12 years, 12 times 12, that's 144 months. So for the last one, we need to put in 144 months. So 1,000 parentheses 1.0075, raise that to the 144th power. So a teeny little bit more than part B. So less than $30 more than part B. But it is slightly better. So 2932.84. So this is 2932.84. Okay. And that will generally be the case. The more often you compound, the better off you are, but it doesn't make a huge difference. So it's not like you compound annually and then you compound quarterly and all of a sudden you're going to have like 3 times as much money or something like that. You're going to do a little better. And then you're going to do a little better if you go monthly after that. You would do a little better if you did weekly, etc. So overall, I mean, it's very similar. He's going to end up with close to $3,000, but you see a little bit of improvement depending on the number of times you compound. And that's all based on 9% interest. If we change the interest, then all bets are off. You'd have to, calculate each one separately again to figure out which one's best. But if I know that the interest rate's going to stay the same, I know that the more often you compound, the better off you are going to be. So in other words, the more money you will earn, the more often your money is compounded for that same interest rate. Okay, so like I said, remember tomorrow we start 5 minutes early and same on Wednesdays. So class starts at 9:05 tomorrow and Wednesday. We are going to take some notes today and tomorrow and finish up our exponential functions. And that means we've got some review coming up at the end of the week because we have our ESA on exponentials next week. It's going to be on Monday and Tuesday. So Monday and Tuesday, Monday will be group B because Monday is a B day. And then Tuesday, group A will be taking the ESA. Wednesday is Veterans Day, so nobody will be on campus on Wednesday of next week, which means that next Thursday we'll be able to start our next chapter on inequalities. That's the greater than and less than problems, the little alligator that eats the bigger number. So that's what we'll be starting next week on Thursday. We'll have one more week and then Thanksgiving. So we have next week and then the following week, then it's Thanksgiving break. And then we are back on campus for 3 weeks after Thanksgiving. Then it's winter break. And then we are pretty much done. So we are going to finish everything by winter break. After winter break, we actually do come back together for 4 days. That first Monday is no school after New Year's, but we'll have 4 days to kind of just clean up and make sure everybody is passing their essentials and you guys are got any late work turned in. So we'll basically have those 4 days for cleanup and then we are done. And when I mean we are done, that means you guys move on and take 4 new classes. And then, of course, I will have brand new students coming in starting that second week of January. So we really don't have that much time left. It has gone by pretty quickly, I think. And remember that you need to pass both semesters of Integrated 1 in order to take Integrated 2 next year. I know some people told me they were taking Integrated 2 next semester, which is fine as well. But again, you have to pass Integrated 1 before you take Integrated 2. And if you are taking it next semester and opted to take 2 math classes this year, that's fine. And if not, you'll be taking it next year. That's what most people will be doing. So most people take 1 math class a year. Although with this 4x4, it did allow for you to take 2 if you decided to sign up for it that way. Okay, so exponentials, that's what we've been doing. And we've been doing y equals a times b to the x. But we talked about exponential growth, specifically with compound interest. So this is what we did on the warm-up today. Remember that you find your multiplier by doing 1 plus, and you take your interest rate and divide it by the number of periods. That's exactly what we did on the warm-up. And x needs to be measured in the number of periods, or the number of times that the money is compounded. And we did examples of that. This was like on Thursday last week. And then on Friday, we just talked about straight growth and decay. So this is not compounding. It's just if you grow by 1%, you do 1 plus your percent. If you decay by 1%, you do 1 minus 1%. And that's how you can find the value B. And then, of course, you need to have an initial value, which would be the value A, or the y-intercept. Okay. Today, this is page 8 of our notes. We are going to start doing something called curve fitting. Curve fitting just means fitting an equation to a graph or to 2 points. And we call it a curve because it is an exponential curve. So in other words, if I give you 2 points, can you figure out what the exponential equation is? And on today's, one of the 2 points will be the y-intercept. So if I give you the y-intercept and one other point, can we figure out what the equation is? And what this involves is figuring out what the value is b, because b is the growth factor. There are 2 pieces to every exponential: the y-intercept, or the starting value if it's a word problem, and the growth factor, the b, the one that's the base and has the exponent on it. So we need both of those things in order to write the exponential equation. So if you are given the y-intercept and you need to solve for b, what we are going to do is step 1. You are going to substitute the y-intercept, because that's your a value, into the equation along with the other point. The other point can be substituted in as x and y. When you put that into your exponential equation, you put in the x, you put in the y, you put in the a. The only thing left is b. So step 2, we solve for b. Now we have a and we have b. So step 3, you write your equation. Okay, so that's basically it. Put in your y-intercept, put in the second point in for x and y, figure out what b is, and then write the exponential equation using a and b. So here's an example. Find the exponential equation that passes through the points 0, 3 and 448. Okay, 0, 3. That's important because notice that the x is 0. So that means the y-intercept, a, is 3. So one of the points you can expect today will be the y-intercept. Tomorrow we'll just figure out what to do if the y-intercept is not one of the 2 points. But today, one of the 2 points will be the y-intercept. So first thing, make sure you know what A is. A is the y-coordinate of the y-intercept. So for this problem, A is 3. The other point, 448. This is going to be a value of x and a value of y. So we're going to take 4 for x, 48 for y. A is 3. Plug it all into our equation. And we're going to be able to figure out the equation of the exponential function that goes through both of these points. Okay, so let's do that. So y equals a times b to the x. So we're going to put in a equals 3. We're going to put in a 4 for x and a 48 for y. I'm going to substitute all 3 of those things into this equation. So 48 equals my a is 3 times my b I do not know, but my x is 4. Parentheses are optional since there's nothing inside the parentheses except for that one value b, so you can drop the parentheses if you want. We usually have them in the general equation just in case, you have some weird number in there or some calculation like 1 plus your interest rate, something like that. But that's where we're at. Okay, so now I need to solve for b. Okay, to solve for b, there are 2 things here that we need to deal with. There's the multiplying by 3, and there is the exponent. We got to work backwards through our order of operations. In other words, we usually get rid of addition first, and then we move multiplication and division next. So we're going to get rid of that 3. And there's no addition and subtraction here, but there is a multiplication. So we're going to move that 3 out of our way by dividing. So 48 divided by 3 is 16. And then over here we have b to the 4th. So the next thing we're going to do is get rid of the exponent. So we have to undo the exponent. Okay? Which brings us to, how do you undo an exponent? So that is a very good question. How do we undo an exponent? And you guys know how to do this when you have, for example, a squared. So if I say x squared is 9, how do you undo the square? And you guys can probably tell me that the answer is 3. But mathematically, what do we do to the 9 to get the 3? Nope. What's that symbol? That's a square root. To undo a squared, we take a square root. So if you have a problem that has an exponent squared, a squared, little exponent, little 2, what do? We take a square root. So if I have an x squared, I know how to undo it. I use a square root. Okay? Now, actually a square root, you may not know this, has a teeny little 2 in the corner there to tell us that it's a square root. We don't usually write the 2. Reason? Square root is the most common kind of root. So it's kind of like, we don't write times 1 and we don't write things that are the most common because there's no point. So we don't write the little 2 when we normally write a square root. However, there are other roots. If you have an x cubed, you have to do a cubed root or a third root. In other words, you got to do a different root. You have to do a root with a little 3 here. This is not a square root. This is a third root or a cubed root. If you have an x to the 4th, you have to do a 4th root. If you have an x to the 10th and you want to undo that, you do a 10th root. It works for any exponent. If I've got an x to a -3, I can actually do a -3rd root. That's okay. So whatever the exponent is, that's the number that you put in the little corner on the root, and your calculator does it for you. So if I had a, 2.5 as an exponent, I could do a root with a 2.5 right there. Calculator will do this for us. So we don't have to know exactly how to do it, because quite frankly, you can't. Mathematically, you cannot do this in your head unless it's something that works out really nicely like this. So on your calculator, you need to know where your root button is. So for example, on this calculator, my root button is located under the button that says math right there. And you'll notice that choice 4 and 5. 4 has the third root, because that's the second most common root, is a third root. And then if I go to number 5, that'll give me a root for whatever other number I want. So if I wanted to do a fourth root, for example, I hit a 4, math, and my fourth root, and now I'm taking a fourth root, which is what I want to do here, because I got b to the fourth, so I want to do a fourth root of 16. So I have to do the fourth root of 16. So that's how it works on a graphing calculator. However, I realize most of you guys do not have a graphing calculator, so we're going to have to figure out where that button is on your calculator. So I would do the fourth root of 16, which is 2. So b equals the fourth root of 16, which is 2. In other words, 2 times 2 is 4, times 2 again is 8, times 2 again, so 4 2s is 16. So you're really figuring out what number can you multiply times itself 4 times to get 16, and the answer is 2. So we now have A, we now have B, so I can now write the answer. This equation is y equals 3 times 2 to the x. Okay, so calculators. If you have and I'm going to put this on the camera for those of you guys online. Okay, if you have a standard scientific type calculator, as I see many of you guys do have a handheld scientific calculator, you will find a root button somewhere. Most likely it is the shift button on your exponent key. So here's my exponent key, that little caret. And then right above it, you will see that it has an X root. It looks like this. So it's got this little root symbol, and then it's got a little X in it. So that can be used for any root that you want. A third root, a fourth root, a fifth root, a sixth root, whatever root you want. So, and I know that this can vary calculator to calculator, but the way that this calculator works, if I want to do a fourth root, I type in the number 4, and then I hit that root, which is blue, so I have to hit second. So second root, and then the X root makes the 4 the index. So this is now going to be a fourth root of 16. So it's not 4 times an X root, it actually is a fourth root. So that's how this calculator works. And this is a common way for a scientific calculator to work. You need to figure out how it works on the calculator that you are using, but this is the button you would be looking for. So on your calculator, you need to look for, oh, I must have a button somewhere that tells me how to take a root, okay? You all have a square root button, and that's the one that doesn't have any little symbol there. So that is the square root key, which is also handy, but it only does a square root. So the disadvantage here is that's a square root only. It's the most common kind of root, but that will not do any other root. If you want to do a third root or a fourth root or a fifth root, you got to find that button, okay? So, and if you're online, you should be able to find it as well. Like I said, it's probably the shift button on your exponent key. I don't know that for sure, but that's usually where the root key is. It's the shift on your exponent. So one of the things you need to do today is make sure that you can find how to do a root on whatever device you are going to be using. Okay. I want to show you guys a second way. Some people don't like doing this, substituting the values into y equals a times b to the x. So I do want to show you that there is another option, and you end up with the exact same thing. So some people like to say, hey, let me just use a table. I have 2 points. My first point is 0, 3. My second point is 4, 48. And I know that there's a bunch of stuff in the middle here that's missing. Okay, how much is missing? Well, I'm going from 0 to 4. So I went a distance of 4. So that means there's 4 spots on my table. To get from 0 to 4, I got to go 4 spots. Every spot I have to multiply by b. So I got to start at 3. And then I got to multiply by b 4 times, which is a b to the 4th. So in other words, to start at 3, my y, that's 3. I got to multiply that y times b to the 4th, and that'll get me to 48. So if you do this, say, hey, I got a 3. I know I got to multiply b to the 4th, and that will get me to 48. Look at that. Magic. This is the exact same equation as that. So if you want to get to the 3 times b to the 4th is 48 by plugging values into y equals a times b to the x, or if you want to get there by visualizing a table or drawing a table, it's the same thing. So I just wanted to point that out to you because I know a lot of you guys have been using tables up until now to figure out what b is. Okay, problem number 2. Find the equation of the exponential f of x given f of 0 is 7. Function notation. Okay, all that is saying is that if you input a 0 into this function, the output is 7. F of 0 equals 7 is the same thing as 0, 7, which, hey, that's my y-intercept. So I now know that a is 7. I also know that f of 6 is 45. That means the other point that I'm going to use is 6, 45. So make sure you know the number in the parentheses is x. The number after the equal sign is the output. That's y. So f of 6 equals 45 is just a fancy way of saying, let's use x equals 6 and y equals 45. 0, 7 means that a is 7. Remember, a is the y coordinate of the y-intercept. So now I'm going to take y equals a times b to the x, and I'm going to plug everything in. My y, I'm going to use 45, equals my a, I'm going to use 7. My b, I don't know, but my x, I'm going to use 6. So if I plug that all in, I end up with 45 equals 7 times b to the 6. Okay. I'm going to get rid of the 7. So we're going to divide by 7. And then if we do that, we end up with b to the 6 equals 45 divided by 7. Now you might notice 45 does not divide evenly by 7. So 45 divided by 7, depending on your calculator, if I do it on here, it'll give me a mixed number. 47 divided by 7 is literally 6 3/7. I can change that to a decimal approximation if I want. It's 6.429 approximately. So you can write that down. So 6.429 is fine. Okay, and that's what b to the 6th is. That's not b, that's b to the 6th. So the last step is, if I want to find out what b is, I got to take a root. What kind of root? You look at the exponent. It's a 6th power. So I'm going to do a 6th root. Okay. And what's cool about the calculator is realize that when I wrote this on my page, I rounded it just because I didn't want to write, 10 digits after the decimal. But when I do it on my calculator, I don't have to round it. I'm going to take the sixth root of 6.429. So that means I have to hit a 6, and I got to go to math and hit my root. So you do whatever button it is to hit your root. And this answer that's sitting right here, 6.429, I'm going to arrow up, copy and paste it, so it's not rounded anymore. And I don't have to take the time to type it all in. It was sitting right there. All I had to do was copy and paste it. So there's my B value, 1.366. 1.3636, I should say. So my B value is 1.3636. So I've got my A is 7. I got my B is 1.3636. So my equation, y equals 7 times 1.3636 to the x. Okay. And again, if you don't like using that equation to plug in, you could set up a table. First point is 0, 7, and then we got a bunch of spaces, and then we get down to 6 and 45. So you say, well, how do I do that? Well, I go 6 spaces over here, which means I have to multiply by B 6 times. So that means I start at 7. I multiply it by B 6 times, and then I get to 45. And that's the same equation that I had right here. So you end up with the same equation either way. So whether you think of it as I'm just plugging values into y equals a times b to the x, or if you think about it as it's a table, how many times do I multiply by b? Because it's a multiplication geometric sequence. You're just multiplying by your multiplier however many times. It doesn't matter. You'll get the same result either way. Yeah, last one is a word problem, because this can work regardless as long as you have 2 different values to look at. So Mrs. Stadler, hey, that's me, bought a car in 2015 for $30,000. It is depreciating in value exponentially at a constant rate. So my car is depreciating every year. It means it's worth less and less each year. In 2020, the car is now worth $25,000. How much do we predict it will be worth in 2022? Okay. Now, I am going to set up a table just for simplicity here. 2015, when I bought the car, it was new and it cost $30,000. So X is going to be the age of the car and Y is going to be the value. So 0, $30,000 is my y-intercept. So this is what's going on in 2015. The year doesn't matter. It doesn't matter what year I bought it. It's all about how old is the car. When I bought the car, it's brand new. Its age is 0. That's my y-intercept. Okay, now it's 2020. I don't care about the year so much as just realizing the car is now 5 years old. So 5 years later, my car is worth $25,000. And then it's asking, how much do I think it would be worth in 2022? In 2022, the car will be 7 years old. It's all about how old is the car. So X, you can just measure that as the number of years, the age of the car. So it's the number of years that have passed since 2015. So right here, that's my y-intercept. So A is $30,000. And then this is the X and the Y that I'm going to substitute into my exponential function. So I've got Y equals A times B to the X. And I'm going to put in 25,000 for Y equals A is 30,000 B, I do not know, but my X is 5. Okay. So I know my A is 30,000, and when X is 5, the Y is 25,000. So I have a value of X and Y that have to work in this equation, which means I can now use this equation to solve for B. So I'm going to divide by 30,000. So always start off dividing by the number next to your B, or your B to the 5th in this case. So 25,000 divided by 30,000. I'll move this over. So 25,000 divided by 30,000. Okay. Now this calculator has the tendency to always, I think it's a setting I've got in there probably in mode. Do I have it set? No. It's doesn't say fraction, just auto. So anyway, this calculator defaults to fractions whenever possible. Nothing wrong with that. 25,000 divided by 30,000 is 5/6. If you don't like the fraction, I can change it. So some calculators default and will give you a decimal. If you don't like the decimal, change it. Okay, your calculator should have a button that converts back and forth between decimal and fraction. But just to be different this time, I'm going to write this as a fraction. So b to the 5th, because remember we got rid of that, we have b to the 5th, equals 25,000 divided by 30,000 is 5/6. Quite frankly, it's just less strokes of my pencil to write that. So that's kind of one of the reasons I like the 5/6. If you don't like the 5/6, it was 0.8333 repeating. To figure out what b is though, I need to take the 5th root of 5/6. And I will need a calculator to do that. Okay? Nobody in here knows what the 5th root of 5/6 is, and I definitely don't. Well, I kind of maybe remember it from last period, but I don't generally know what the 5th root of 5/6 is. So 5 math root, and I can put in what happened, 5/6. So I'm going to take the 5th root of 5/6. Now that fraction I do not like, because the whole point of me writing 5/6 is that it was easier to write than the decimal form. That is not easy to write. 9,236, 9,579. So I'm definitely going to change that to a decimal. So it really just comes down to what's the easier way to write it. So 0.9642 to me is much easier. That means my car is losing about 4% of its value every year, because that's about 96%. Okay, how much is my car going to be worth in 2022? So Y equals my original value multiplied by my B raised to the 7th power. I want to know how much will my car be worth when it's 7 years old, because that's what 2022 represents, the car in 7 years from when it was bought. So how much will a 7-year-old car be worth? That started at $30,000 and is depreciating at the rate of the B that's there. So again, I go to my calculator and I type in 30,000 parentheses. Oh, I'm going to do this cut and paste thing again. So if I copy and paste that number right there, I didn't do any rounding. So this is going to make sure that it's accurate as much as I need it to be accurate. Specifically, I'm going to round to the dollars and cents. So in 2022, I predict my car will be worth $23,241.68. So $23,241. And now I forgot the cents, 68 cents. Okay. So there is our prediction based off of our exponential model of what's been going on so far. Okay, so bottom line is, if you know the y-intercept, and today you will know the y-intercept, you can substitute it into the equation for A, and then if you know one other point, you can substitute that one other point for X and Y, and then you can solve for B. It will involve taking some type of root. Might be a square root, but it might be some other type of root as well, like a third root or a fourth root. We just did a fifth root on this problem. So whatever the exponent is, that's the kind of root you're going to have to use to solve for B. And then once you solve for B, then you can set up your equation and you can answer questions based off of the model. So make sure, first off, that you know where the root button is on your calculator. So whichever calculator you're using today, whichever device you're going to be using when we do our ESA, make sure you know how to find a root button and use it. Okay, those of you guys that are in class, if you don't know where it is on your device, I am happy to help you out. Those of you guys that are at home, if you can't figure out where that root button is, holler out. You can screen share with me and show me where your calculator is, and we can try to figure out together where it is. It's usually the second key, the shift on the exponent. That's usually where it is, but I can't guarantee that that's the case for every single calculator that has ever been made. So if you have a different type of calculator, we might have to look at that. But you can't do the delta math tonight if you cannot take a root. So make sure you have a way to take a root. Even if it's, you know, go to Google and Google the fifth root of, 1,000, and Google does it for you. So make sure that you can take whatever root you need. Okay? So I'm going to go ahead and stop the recording because I think we're good.